Here's the third video of section 1.5, and it's rational functions. A rational function is formed when a polynomial is divided by another polynomial. And in fact, basically, if you notice a fraction, then it's rational, usually. Rational functions can be used to model examples that occur naturally in many contexts. Definition of rational functions. A rational function is a function of the form r of x when p of x is divided by q of x, and p of x and q of x are polynomials. So if you have one polynomial divided by another polynomial, that's a rational function. And because it's a fraction, there are certain things that you have to look at, and one is vertical asymptotes. Recall, the vertical asymptote is found where q of x is equal to 0. So if this is our function r of x, all right, I have a polynomial on the numerator divided by, sorry, let me get rid of this, a polynomial in the denominator, I'm sorry. If that equals 0 in the denominator, then that gives rise to a vertical asymptote x equals k. So it's going to be a, sorry, let me erase that again. It's hard to do it with this sometimes. It's going to be a line that you don't see, that it's going to be an x equals something, a number, in this case x equals k, that your function will approach but never really touch. That's an asymptote. Okay, so let's look at this function. So we're just going to put here, so to do a vertical asymptote, you take your denominator and put it equal to 0. Okay, so that's the first one we're looking at. All right, so here I have a function here. I want to find if there's any vertical asymptotes. So I take my denominator, x squared minus 7x minus 8, and I put it equal to 0. And when I do this, I can actually factor this. So I have x minus 8, x plus 1. Make my big T here. X minus 8 equals 0. X plus 1 equals 0. So x equals 8. That's a positive 8, everybody. It's an equal signs. And x equals negative 1. So I have two vertical asymptotes in this case. Okay. Now it says find the vertical asymptotes of x squared minus 7x minus 8. And it kind of goes through the solution that you do here is as you can factor it, and see how this is x plus 1 on the top. Well, I can factor the bottom, make it equal to 0, and reduce it down. See how it makes a 1? So then I have this. When one of the factors of the denominator cancels with the numerator, that factor does not produce a vertical asymptote. Instead, we have a whole. X equals 8 is the only vertical asymptote, and the whole is at x equals negative 1. So we're going to see some of those examples. I just wanted to show you that vertical asymptote. Long-range behavior is another thing we look at. So this is the second thing we look at, which basically is our horizontal asymptote, and we'll be looking at that. So when we refer to long-range behavior, we mean do the y values approach some finite number as x approach either negative or positive infinity. So if we want to look at the long-range behavior, so we're approaching either negative or positive infinity, I put this in my calculator, and I showed that it looks like as I'm getting bigger and bigger and bigger, right here, I'm approaching this. And when I'm getting smaller and smaller and smaller, I'm approaching the same thing. So it looks like that my function is approaching negative 0.4 as it goes to positive or negative infinity. Okay? How you can look at that is you can take these two, and I'll show you some shortcuts. These two right here, I have the same power. If I cancel out the powers, I get a negative 2/5. So that's my horizontal asymptote, is y equals negative 2/5, or our horizontal asymptote. So let's look at the next page. When we look at the long-range behavior of rational functions, we're actually finding the horizontal asymptote like I told you. How to find it? You can plug in very large values of x and look at this behavior and see where it's going to. In this function right here, when I plugged it in here, it looks like I'm getting very, very small, close to 0. It looks like I'm going to y equals 0. And if I were going to look at this, if I looked at this has a power of 1, it has a power of 2. If the power at the bottom is larger than the power of the top, the horizontal asymptote is y equals 0. It's something you just got to memorize. Okay? And if we find the horizontal asymptote of this one right here, it looks very similar to the one above, but if you see how the power on the top is larger than the power in the denominator, therefore this has no horizontal asymptote. So I'm going to kind of recap this because there's 3 rules that you should know about horizontal asymptotes. Okay? So finding them, so here's our 3 rules down here. If the degree of the numerator is less than the degree of the denominator, this is the first case, sorry, this is number 1, then it's y equals 0. If the degree of the numerator equals the degree of the numerator, you take your leading coefficient of the numerator and the denominator and then use both of them. Then I always call this numerator over denominator. This is like the most fun one to do. And this is the second case. And the third case is if the numerator power is greater, or the degree is greater of the numerator, then there is no horizontal asymptote. So you don't have to have one. And we're going to practice some so you'll see how this works. So we're going to find all the horizontal and vertical asymptotes, all right, of these two. So vertical asymptote is you take your denominator and put it equal to 0. To find horizontal asymptote, you have to use your numerator and your denominator, and there's 3 cases that you have to look at. This one is an x equals a line. This is y equals a line. Okay? These are both lines. So here I look at this one. If I take my denominator equal to 0, you'll see that I would get x is 2. That is my vertical asymptote. Here, my powers are the same, so if I look at 2 of those, so here is the work for this one. I'd put 3x over negative 2x. This will cancel out. There you get the y equals negative 3/2. Let me show you for the work for this one. Okay? Here, the second one, vertical asymptote, take my denominator, put it equal to 0. When I do that, I get x to the 4th plus 1 equals 0, and if I do x to the 4th, if I move that 1 over, I get a negative 1. That'll never happen, so there is none. You don't have to have it, okay? Over here, if I did the horizontal asymptote, I would take just the power with the coefficient on the top over the highest power in the denominator, and if you see how that's larger, that's that one case where you have to memorize, if it's larger at the bottom, the power is y equals 0. Here, my vertical asymptote, I take my denominator, put it equal to 0, and if I solve this, I have x plus 1 equals 0, and x minus 1 equals 0. That's where I get those 2 vertical asymptotes. And then for the horizontal asymptote, I have to use the highest power in the coefficient of the numerator and the highest power in the denominator. And if you see that that's smaller, then there is none. So those are the 3 cases. All right? Finding the zeros of the rational function, you're going to set your numerator equal to 0. And the one thing I want to show you in this one, just a second guys, I kind of froze up here. If it comes back, kind of froze up on me. So what I'm going to do is try to stop this, if it lets me. Hang on a second. I'm going to go back to this page and come here. There we go. I was a little frozen there. That happens. So to find the zeros of a rational function, you're going to set the numerator of the function equal to 0 and solve for x. So I just want you guys to know, when you do zeros of rational function, you're talking roots. And roots are on your x-axis, so they're usually a number 0. So if you put your y equal to 0 and solve for this and cross multiply, see how I did it here? You will go x equals 5/2, and that is your 0, or the point 5/2 0. Okay? Finding x-intercepts, okay, all x-intercepts are number 0, so it's a point. So you place a 0 in for your y value, and it will give you the x-intercept. That's what I just showed you. Okay? Finding y-intercepts, it's a point 0, a number. So I'm going to put zeros in for x's, and you will find your y-intercepts. So I've kind of given you the notes for all these. There's like 4 things we find. We find the horizontal asymptote, the vertical asymptote, the x-intercepts, this is the third one, and the y-intercepts. So we're going to practice some on the next page. We're going to do of each one. And remember, you don't have to have any of those categories. So let's practice this. All right, let's do this first one together. Okay. So I have this rational function. It's a fraction. So I've got it all set up. I've got VA is for vertical asymptote. Remember that your denominator equal to 0. Your horizontal asymptote is you're going to use your numerator and your denominator. X-intercepts is a number 0. Y-intercepts are 0, a number. So then it tells you how to find it. Remember, these first two are lines, these two are points. So this, I want to show an x equals line, a y equals line, and an actual point. So if I take my denominator, put it equal to 0, I have x plus 1 equals 0, x equals negative 1, so there is my vertical asymptote. There is one, and I found it. Horizontal asymptote, remember, use your numerator and denominator, the highest power, so I got 3x as my highest power over the x. They cancel out, so I get y equals 3. So that is my horizontal asymptote. It approaches that. X-intercept is a number 0, so I'm going to put a 0 in for my y value. So 0 equals 3x minus 2 over x plus 1. And if I cross multiply, I had 3x minus 2 equals 0. 3x equals 2. X equals 2/3. So the point 2/3 0 is, it's where it crosses the x-axis, excuse me. My y-intercept is where I put 0 in for x's, so I have 3 times 0 minus 2 all over 0 plus 1. I have negative 2 over a positive 1, so this is the point 0, negative 2. So we just practice those. So now I found all this. Now, when we get to class, we're going to practice graphing this, but I wanted to show you how you can look at that function and find this information just by knowing how to do this, okay? I have another rational function. Remember, vertical asymptote is denominator equal to 0. Horizontal asymptote is numerator over your denominator. X-intercept is a number 0. Y-intercept is 0, a number. So let's try this. Denominator, x squared minus 4 equals 0. X minus 2 times x plus 2 equals 0. Draw my big T. X is going to equal a positive 2. X is going to equal a negative 2. So I have two vertical asymptotes right there. They're both lines. Horizontal asymptote, take my highest power of the numerator with the coefficient and the highest power in the denominator. They match. I can cross that off, say thanks for playing. So y equals 5 is my horizontal asymptote. X-intercept, excuse me, I'm going to put 0 in for y. And when I do that and cross multiply, you'll see I'll have 5x squared plus 1 equals 0. 5x squared will never equal a negative 1, so there is none. You don't have to have an x-intercept. It might not cross the x-axis at all. And the y-intercept here. Y-intercept is 0, a number, so I put 0 in for x's, so I have 5 times 0 squared plus 1 all over 0 squared minus 4. So I have a negative 1/4, so my point is 0, negative 1/4. That's where it does cross the y-axis. So if you want to shut the tape off, I'm going to keep going and try these last two to see how you do. I'm going to expect you to be able to do all this, and we're going to practice graphing these in class. So shut it off and then see if you can do it and then come back. Vertical asymptote, I'll just do the work for it. Remember, it's your denominator equal to 0. So I do x squared plus 1 equals 0. Guess what? X squared will never equal a negative 1. So there is none. You don't have to have a vertical asymptote. Horizontal asymptote is where I use my highest power and coefficient in the numerator, highest power and coefficient in the denominator. This is larger than the top. This is one of those cases, so this is the one you have to memorize. The power is larger, so y equals 0 is my horizontal asymptote. X-intercept is a number 0, so I'm going to put 0 in for y. And when I go to do this, cross multiply, I have 2x equals 0, or x equals 0. So my x-intercept is the point 0, 0, which is your origin. Y-intercept is 0, a number, so I'm going to put 0 in for x's. So I have 0 over 1, so I get 0. Again, this will also be my y-intercept because it's the origin, so it's both. And lastly, we have this one right here. Vertical asymptote, I take the denominator, put it equal to 0. That lets me write. Let's try this again. There we go. X equals 1, my vertical asymptote. Numerator and denominator, highest power, make sure the sign goes with it. I have a negative, the power at the bottom is smaller than the power at the top, so this one is none. There is no horizontal asymptote. X-intercept is a number 0, so I put 0 in for y. And when I do that, cross multiply, I get 3 minus x squared equals 0. So I get x squared equals 3. So x is going to be positive or negative radical 3. So I have two x-intercepts. I have a positive radical 3, 0, and a negative radical 3, 0. Please make sure you're careful on that, because if you don't put plus or minus, you might miss one of the x-intercepts. And the y-intercept is when I put x 0, so I have 3 minus 0 squared over 0 minus 1. So I have 3 over negative 1, or negative 3. So my y-intercept is 0, negative 3. And like I said, we're going to practice graphing these because I want to be able to have you go both ways. So that concludes this video.